Mercury. The name conjures up images of quicksilver, thermometers, and perhaps even the fleet-footed Roman messenger god. But what about a scorching, sun-baked world? That's Mercury too, the smallest planet in our solar system and the closest to the sun. It's a place of extremes where temperatures swing wildly from blistering hot to unimaginably cold. Imagine a place where the sun blazes down with unrelenting fury, baking the surface to temperatures hotter than a pizza oven. That's Mercury, our celestial neighbor and the protagonist of our story. But why is Mercury so hot? The answer lies in its unique position in our solar system and some intriguing planetary characteristics. Join us as we delve into the heart of this fiery world and uncover the scorching truth behind Mercury's extreme temperatures. Mercury is a tiny traveler in the vast expanse of our solar system. Its orbit is the smallest and fastest, taking it on a whirlwind journey around the Sun in just 88 Earth days. This proximity to our star is the primary reason for Mercury's intense heat. Think of it like standing close to a bonfire. The closer you are, the more intense the heat you feel. This is because the Sun's energy, in the form of radiation, spreads out as it travels through space. The closer an object is to the Sun, the more concentrated the radiation it receives. Mercury, being the Sun's closest neighbor, bears the brunt of this intense radiation. This constant bombardment of solar energy is the primary driver behind Mercury's extreme temperatures. It's like having a front-row seat to the most powerful energy source in our solar system. But Mercury's story is not just about scorching heat. It's also about a planet stripped bare, lacking the protective blanket of an atmosphere. This lack of atmosphere leads to extreme temperature swings. Without a substantial atmosphere, Mercury's surface experiences drastic changes. The side facing the Sun bakes in intense solar radiation, while the side facing away plunges into frigid darkness. Mercury is a planet of two extremes, a furnace and a freezer. Mercury holds the title of the Sun's closest planetary companion. While the Earth maintains a comfortable 93 million miles from the Sun, Mercury orbits at a mere 36 million miles, a distance that seems almost impossibly close. This proximity is the primary culprit behind Mercury's extreme temperatures. Imagine a spacecraft venturing close to the Sun, its heat shield glowing with the intensity of 1,000 suns. That's the kind of energy Mercury contends with every single moment of its existence. The Sun, a giant ball of scorching plasma, bathes Mercury in a constant, unrelenting flood of heat. This proximity means that the amount of solar radiation reaching Mercury is far greater than that reaching Earth. It's like comparing a whisper to a shout. The closer you are, the louder the sound. Similarly, the closer a planet is to the Sun, the more intense the solar radiation it receives. Solar radiation, the energy emitted by the Sun, travels through the vast emptiness of space at the speed of light. This energy arrives in various forms, including visible light, ultraviolet radiation, and infrared radiation. When this radiation strikes an object, like a planet, it transfers some of its energy as heat. Think of a magnifying glass focusing sunlight onto a leaf. The concentrated energy quickly heats the leaf, causing it to burn. Similarly, Mercury's proximity to the Sun means it receives a highly concentrated dose of solar radiation, leading to scorching surface temperatures. This constant barrage of solar energy is the primary reason why Mercury experiences such extreme heat. It's like being placed under a cosmic magnifying glass, with the Sun's energy constantly bombarding the planet's surface. To understand the impact of distance on temperature, imagine two identical houses, one painted black and the other painted white. On a sunny day, the black house will absorb more sunlight and become much hotter than the white house, which reflects more sunlight. Similarly, Mercury's proximity to the Sun means it absorbs a greater amount of solar radiation, leading to higher temperatures. The relationship between distance and temperature is not linear. As a planet moves closer to the Sun, the amount of solar radiation it receives increases exponentially. This means that even a small difference in distance can result in a significant difference in temperature. Mercury's close proximity to the Sun is the single most important factor in its extreme temperatures. It's a constant reminder of the immense power of our star and the profound influence it exerts on its planetary companions. Unlike Earth, swaddled in its comforting atmospheric blanket, Mercury stands exposed, practically naked to the cosmos. Its atmosphere is so thin that scientists call it an exosphere, a barely-there veil that offers little protection from the sun's relentless glare. Imagine trying to stay warm on a frigid night with only a thin sheet for cover. You'd feel the chill right through the fabric. That's what it's like for Mercury, constantly bombarded by solar radiation with only a wisp of an atmosphere to offer any resistance. This lack of a substantial atmosphere is another key reason why Mercury experiences such extreme temperature variations. It's like leaving a pot of water outside on a scorching day. Without a lid to trap the moisture, the water will quickly evaporate. Similarly, Mercury's thin atmosphere provides little insulation, allowing heat to escape easily back into space. Earth's atmosphere acts like a giant greenhouse, trapping heat and keeping our planet habitable. Gases like carbon dioxide absorb infrared radiation, preventing it from escaping. But Mercury's exosphere is too thin to trap heat. Atoms are bombarded by solar wind and escape Mercury's weak gravity. Without effective heat trapping, Mercury's surface faces extreme temperature variations. Mercury's lack of a significant atmosphere and its slow rotation create a stark dichotomy between its day and night sides. The side facing the sun bakes in the full intensity of solar radiation, reaching temperatures hot enough to melt lead. Meanwhile, the side facing away from the sun plunges into a frigid darkness that can only be described as otherworldly. Imagine stepping from a scorching desert into a freezer within a single stride. That's the kind of temperature swing you'd experience on Mercury, where the difference between day and night temperatures is the most extreme in our solar system. This stark contrast is a direct result of Mercury's inability to retain heat. Without an atmosphere to distribute the sun's energy, the day side bakes while the night side freezes, a celestial tug-of-war between scorching heat and frigid cold. While the day side of Mercury roasts under the sun's intense glare, its night side remains shrouded in an eternal, bone-chilling darkness. Temperatures plummet to hundreds of degrees below freezing, cold enough to freeze gases into ice. This extreme cold is a direct consequence of Mercury's slow rotation and its inability to retain heat. Imagine a world where the sun never rises, where the stars are always visible, and where the ground is forever encased in a layer of frozen gas. That's the reality on Mercury's night side, a place of perpetual darkness and unimaginable cold. This stark contrast between day and night highlights the crucial role an atmosphere plays in regulating a planet's temperature. It's a reminder that even in the vastness of space, seemingly small details can have a profound impact on a planet's environment. Unlike Earth's brisk 24-hour rotation, Mercury takes its sweet time. One full rotation, a Mercurian day, takes 59 Earth days. This slow spin, coupled with its swift 88-day orbit, creates a bizarre dance between day and night. Imagine a day that stretches for months, the sun seemingly frozen in the sky, baking the land beneath its relentless glare. As Mercury slowly revolves around the sun, its day side bakes in the intense solar radiation for an extended period. Temperatures soar to a staggering 800 degrees Fahrenheit, hot enough to melt lead and turn rocks into molten goo. This intense heat is a testament to the sun's power and the unforgiving nature of space. Imagine a landscape devoid of life, where the ground cracks and heaves under the intense heat, and where mountains cast long, black shadows across the barren plains. That's the day side of Mercury, a scorching inferno where even the most resilient spacecraft would struggle to survive. But as Mercury continues its slow rotation, the day side eventually gives way to the night side, and the temperature plummets with astonishing speed. Without an atmosphere to trap heat, the surface radiates its energy back into space, and temperatures plunge to hundreds of degrees below freezing. In contrast to Mercury's languid spin, Earth pirouettes on its axis at a relatively brisk pace, completing one rotation every 24 hours. This rapid rotation, combined with our planet's tilted axis, creates the cycle of day and night we experience, with moderate temperature variations between the two. Imagine standing on Earth, feeling the warmth of the sun on your face as it arcs across the sky. As day transitions to night, the temperature gradually cools, but the change is gentle thanks to our atmosphere's ability to trap heat. Earth's relatively fast rotation ensures that no part of the planet is subjected to the sun's intense heat for too long. This, combined with our atmosphere's protective blanket, allows for the existence of liquid water, a stable climate, and ultimately, life as we know it. Section 4. A lopsided world. Mercury's slow rotation and proximity to the sun create stark contrasts, with scorching days and frigid nights. The temperature difference is the most extreme in our solar system. It's a testament to the power of our star. Imagine experiencing searing heat and bone-chilling cold within a single rotation. That's Mercury, a planet of extremes. Section 1. Mercury's Inferno. When it comes to scorching temperatures, Mercury often steals the show. Its dayside surface, bathed in relentless solar radiation, can reach a staggering 800 degrees Fahrenheit, or 430 degrees Celsius. That's hot enough to melt lead and turn many metals into a puddle. Imagine a landscape where rocks glow red with heat, and any visiting spacecraft would need serious thermal protection. That's Mercury at its most extreme. The lack of a substantial atmosphere means there's nothing to moderate the sun's intense energy, leading to these mind-boggling temperatures. While Mercury might hold the record for the largest temperature swings, it's essential to note that it's not actually the hottest planet in our solar system. That title belongs to Venus, a planet shrouded in a thick, toxic atmosphere that traps heat like a furnace. Venus, a hothouse world. Venus, Earth's evil twin, has an average surface temperature of 867 degrees Fahrenheit. It's hotter than Mercury, despite being farther from the sun. The secret lies in its dense, carbon dioxide-rich atmosphere. Think of Venus as a pressure cooker on a cosmic stovetop. Its thick atmosphere creates a runaway greenhouse effect, trapping solar radiation. Even the night side remains hot due to global heat circulation. Venus is a cautionary tale about the runaway greenhouse effect. Section 3. Beyond the frost line. As we venture farther away from the sun, beyond the orbit of Mars, temperatures plummet dramatically. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas giants, composed primarily of hydrogen and helium, with frigid temperatures that make Mercury's Inferno seem like a tropical paradise. Imagine a world where temperatures plunge hundreds of degrees below zero, where gases freeze into ice crystals, and where storms rage for centuries. That's the reality of the outer solar system, where the sun's warmth is a distant memory. While these gas giants might lack a solid surface in the traditional sense, their atmospheres are dynamic and complex, with swirling storms, powerful winds, and temperatures that would instantly freeze any earthly life form. These frozen behemoths serve as a stark reminder of the vast temperature differences that exist within our solar system. Section 4. A unique place in the solar system. Mercury's extreme temperatures, while not the hottest in the solar system, highlight the unique challenges and wonders of our cosmic neighborhood. From the scorching inferno of Mercury's dayside to the frozen wastelands of the outer planets, our solar system is a place of incredible diversity, where temperature plays a crucial role in shaping the evolution and habitability of planets. Understanding the factors that drive these temperature variations, from proximity to the sun to atmospheric composition, is essential as we explore our cosmic backyard and search for signs of life beyond Earth. Mercury's scorching truth reminds us that our solar system is a place of extremes, where the laws of physics create a breathtaking tapestry of fire and ice, and where even the most seemingly inhospitable worlds hold secrets waiting to be uncovered. A study in extremes. From searing heat to frigid chill, Mercury is a testament to solar system extremes. Its close dance with the sun and thin atmosphere create dramatic contrasts. We've journeyed across scorched plains and shadowed craters where eternal darkness and unimaginable cold reign. Mercury's extremes are due to its proximity to the sun and lack of atmosphere. It's a reminder of our solar system's incredible diversity. A study in extremes, showcasing the sun's power and planetary balance. The universe beckons. As we explore our cosmic neighborhood, our planet is a true oasis in space. Mercury's extremes remind us of the challenges in the cosmos. When you gaze at the night sky and spot Mercury, appreciate its story. It's a tale of physics and the universe's wonders. The cosmos beckons, and Mercury reminds us of adventures beyond our comfort zone.